Hello Shivam, you are a good boy. Sit. Okay. So first of all, the thing is that you guys who come offline, you are missing the offline classes, you are going online. Now this is not done, you know, because if there is one class, so I will take it online. This is next time if you do such thing, I won't allow you to take my classes. Okay, there are few rules that you have to apply. Okay, Gauranshi, tell this to all your friends. Even I can take the classes, I am injured, I can take the online classes. I am not a fool, I am standing here and taking the classes and you guys are not even coming for the classes. Okay. So today we are going to start with SHM. Okay. But before going for SHM, we have to understand what oscillation is. So put on the heading oscillations. I am not audible. Am I audible now? Can you hear? Okay, so I have to repeat myself once again. First of all, the students who come offline to take the classes and they are taking the classes online, this is the last time that I am permitting you for so. Okay? Next time I won't permit you to take any class like this. Because I am not a fool. Even I can take the classes online, sitting back at home. I am all injured, but I come here to take the classes and you people that there is only single classes, so I won't go. So this type of tantrum I won't tolerate.
सर वो एक्चुअली मेरे जो गाड़ी है उसका एक्सीडेंट हो गया था, इस वजह से मैं नहीं आ पाई.
आप नहीं आ पाए, गौरांशी नहीं है, निकिता रावत and all these people are taking the classes online. Okay. Today we are going to start with a new chapter, that is oscillations. Okay. Now, what is oscillation?
एक फिक्स्ड पोजीशन से टू एंड फ्रो मोशन होना.
The motion of a body about a fixed position.
To and fro motion of a body. Oh. No, that is not oscillation. Anyone else? What is oscillation? Bookish definitions, wrong.
Then regular time intervals में to and from motion करना एक फिक्स्ड पोजीशन से.
And that fixed position, at that fixed position, total force is 0.
That fixed position. To understand properly what oscillation is, and see, from today we have started with waves. First we are going to complete SHM oscillations, and then we are going to do waves, and then wave optics, and then ray optics. So 1 month we are going to dedicate to these portions, so pay attention from today. Okay, and I will try that it becomes uncomfortable for those who come on offline and today they are online. So, first of all, let's understand what periodic motion is. Yes, Shoki, you were saying that to and fro motion from a fixed position, that's what oscillation is. So what is periodic motion?
Sir, motion which repeats itself in every interval of time.
Okay, so here also that means body is repeating the motion in a regular interval of time. So it is doing to and fro motion, that's what to and fro motion is. And from a fixed position, the thing, you are just changing the words. Reshma, Shoki, pay attention, you are just changing the words. You are saying that to and fro motion is in a regular interval of time is your oscillatory motion or it is oscillation. And then you are saying that periodic motion, when, what did you say about periodic? That it repeats itself. So my dear, to and fro motion also repeats itself. Yes or no? But to and fro motion भी तो repeat होगा. It is also repeating itself.
सर मतलब सर ऐसा बोलना चाहता हूँ मैं कि ऑसिलेटरी में बेशक आगे पीछे हो, लेफ्ट राइट हो, लेकिन पीरियोडिक में कुछ भी हो सकता है.
लेफ्ट राइट हो, पीरियोडिक में कुछ भी हो सकता है. वो रैंडम
पीरियोडिक मोशन एक लार्ज वैरायटी है, उसके अंडर में ऑसिलेशन आता है.
यस सर.
Because सर्कुलर मोशन भी पीरियोडिक है, बट उसमें नेट लाइक उसमें मेन पोजीशन नहीं है, और ऑसिलेशन में एक मेन पोजीशन है जिसके.
So what is the difference? What extra condition should a body have to perform oscillatory motion? Periodic motion, let me tell you what periodic is first. Repeated motion in a regular interval of time. Regular interval or fixed interval. Okay? If something is repeating itself in a fixed interval, that is periodic. Fine. For example, suppose there is a wall and an ant is trying to crawl this wall. So ant is big. It is trying to crawl this wall. It is moving up. Now it reaches a particular position, say 10 meters. And when it reaches this position of 10 meters, it falls down. After reaching 10 meters, this ant falls down. Again, it moves up 10 meters, again it falls down, and so on. Getting my point?
So this is periodic but not oscillation.
Yes, I am giving the example of periodic only. Okay, again it moves up and again it falls down. This is repeated in fixed interval of time. Let's say it takes 5 seconds to reach to the 10 meters and then it falls down. Then again it takes 5 seconds to reach up and then again it falls down. This is periodic motion.
Yes, sir.
So it is not necessary that periodic motion has to be circular. This is also periodic motion. Yes or no? There is an example given in the NCERT that a baby is trying to walk on the staircase. So he puts or he climbs one step. It takes him 2 seconds to climb one step and 1 second to decline from that step. What I mean is he climbs one step and then he comes back again to the ground level. He again climbs that step, again comes back. Time is 2 seconds for climbing and 1 second for declining. this is a periodic motion. Every time he is climbing and every time he is coming down. Yes or no? Getting my point or not, everyone?
Yes, sir.
Yes, sir.
Yes, sir.
Okay. Now, school bell. Your school bell rings at 8 a.m. every morning. School bell rings at 8 a.m. every morning. First bell of school. Periodic. This ringing of school bell is periodic. It is repeating itself in a regular interval of time. So anything that is going to repeat itself in a regular interval of time is known as periodic motion. Clear or not? Okay, you can write these examples.
Yes, sir.
Ritika, dear, you are here for the demo. Are you able to understand what periodic motion is? You have to respond dear. If you are not understanding, please speak. Okay. I can also draw graphs for this, for the motion of hand. Something like this. Yes or no? 0 to 5, then 5 to 10, 10 to 15. Here time is given in seconds. Okay, and here distance is given in meters. This is 10 meters. So it is climbing. In 2.5 seconds it climbs and then it comes down again in 2.5 seconds. Same process is repeated for hand. Okay, this is periodic motion.
Yes, sir.
Yes, sir.
Okay. I can also draw graph for, please note it down, then I will do it for the baby. Note it. Okay.
Done.
Yes, understood everyone? Ritika, did you get it or not? Okay.
Got it, sir.
Now, if I talk about steps taken by the baby, for that too, graph can be plotted. This is the distance, this is the time. So let's say baby takes 0 to 3 seconds. Then he climbs, let's say height of the step is 2 meters. So then he reaches here, he stays there for 2 seconds, then again he comes down. So 2 seconds now from 5 to 8 he will stay down. Again he will reach up 8 to 10. Again he will come down from 10 to 13. This is also a periodic motion. baby trying to climb the step. He climbs, then again he comes down, climbs, again he comes down. Also an example of periodic motion. Revolution of Earth around the sun. Again periodic motion. Yes?
Yes, sir.
So all these are periodic motions. Noted. Done? Can I proceed?
Yes.
Okay. Moving on. What do you think about UCM? What type of motion is UCM?
Sir, periodic.
Periodic, but not oscillation.
You don't know anything about oscillation, Shireen. I haven't told a thing about oscillation. So let's just talk about periodic for now. UCM is, yeah, it is periodic motion. Why? Because body is, let's call this position as A. Continuously, body is moving from A and then again it is returning back to A. It is starting from A, returning back to A. Starting from A, returning back to A. Continuously. Such type of motion is known as periodic motion. So yes, UCM is a periodic motion. Understood?
Yes, sir.
Now let's talk about oscillatory motion. Yes, Madam Shireen. Now tell me what is oscillatory motion.
So what is UCM, sir?
Okay, Ritika. Good, you spoke. Have you understood what is periodic motion, Ritika? Because you were facing problem.
Sir, now only I have joined, sir, because of some issues.
Okay, you haven't heard anything. Okay, so first of all, understand what is periodic motion. Periodic motion means a motion which is repeated after regular interval of time. That is periodic motion. What I mean by this? For example, let's say an ant is trying to crawl the wall. So the ant crawls 10 meters of the wall and then it falls down. Again it crawls 10 meters, it falls down. So if it is climbing the wall in 5 seconds and it is again falling down in 5 seconds, this is periodic motion because it is repeating itself in regular interval of time. Let's say there is a baby who is trying to climb the staircase. He climbs first step, takes him 3 seconds, then again he comes down, declines. Again he climbs, takes 3 seconds, again he comes down. This is also periodic because same type of motion is repeating itself after regular interval of time. Getting my point or not, Ritika? Yes, where are you?
Yes, sir.
Yeah, please keep on speaking because I am doing it again for you. Now, motion of planets around the sun, that is periodic. Rotation of Earth, revolution of Earth around the sun, it is periodic because it takes fixed amount of time, right? 1 year. Earth takes 1 year to revolve around the sun. Periodic. Okay. Now, UCM means uniform circular motion. Understood or not, Ritika?
Yes, sir, understand.
So in uniform circular motion, velocity changes but speed is constant. So this motion is repeated in a fixed pattern, path is fixed and it is repeated in a regular interval of time. So UCM is also a periodic motion. Got it?
Got it, sir.
Now, what is oscillation? What is oscillatory motion? Yes, Shireen. Again the same question.
Motion which is done about its mean position.
About the mean position? What do you mean by mean position?
Sir, it is a fixed position where the net force is zero.
Net force is zero?
Yes, at that point, I can say that total force gets zero.
Total force gets zero. Okay. Anyone? What is
सर
oscillation?
कोई ऐसा मोशन जिसके अंदर कोई रीचुअल फोर्स का काउंट लगता है सेंटर की तरफ।
Come again. Torque what?
सर कोई ऐसा मोशन जिसके अंदर सेंटर की तरफ रीचुअल फोर्स या फिर टॉर्क लगता हो।
थोड़ा बहुत सही है. Now see, oscillatory motion is a type of periodic motion. To and fro motion, that was also to and fro motion, Gaurav. Oscillatory motion is a type of periodic motion, but it has got some distinctive property of its own. There is a property which distinguishes oscillatory motion from periodic motion. What is that property? Let us understand. Suppose this is some vessel and here you have put some mass M, let's call it M. Okay. Now, if you apply force on this mass, you apply the force F and bring this mass to this point A. What will happen, Ritika, you tell me, what will happen when you remove the force? You have applied external force like this and you brought this mass to the position A. What will happen when you withdraw the force? Yes, Ritika.
It will come down, sir.
It will come down, obviously. As soon as you will remove the external force, this mass is going to slide down. To which position? Let's say this position is O. It will come back to O. Yes or no, Shivam?
Yes, sir.
Okay. Apply the force in this direction. Let's call this point as B and bring it to this point F. Apply the F, bring it to B. Once again, when you will remove the force, this block or mass is going to slide back. It will come back to O.
Yes, sir.
Right or wrong? Yeah. Now my question is, according to Newton's laws, it's not a question first, it's a statement. According to Newton's laws, body will stay in its position until and unless a force is applied to it. Yes or no?
Yes.
Speak, guys. What are you waiting?
Yes, sir.
So, this mass, why is it moving back? If it is moving back to the position O, that means some force is acting on this mass.
Yes, sir.
Yes, sir.
Some force is acting on this mass which is bringing it back to position O. Ritika, are you getting it or not?
Yes.
Why is it moving back to O? Why is it moving back to O? Because some force must be acting on it. That's why it is moving back to O.
Yes, sir.
We call this force as restoring force. This force is known as restoring force. Why do we call it restoring? Because it is bringing the body back to its original position. Restore, wapas lana. It is bringing the body back to its original position. That is why it is restoring force. So, a force is actually acting on this mass. Let's call it Fr, which is bringing the body back to its original position. Got it or not? Everyone? Yes or no? This is example number 1. Look here. Example number 2. Suppose I have got a pendulum. I have got a pendulum. Now this position where pendulum is at present, where it is at rest, let me call this position as O. Okay. Now what you do, you apply the force on the pendulum. Apply the force on the pendulum. So what will happen? Pendulum will start oscillating. Right? So that means it will move from this position to this position under the influence of the force that you apply. Right? Then what will happen? Pendulum will come back. If pendulum is coming back to this position O, that means a restoring force is acting on it. Under the influence of restoring force, it is coming back. Tell me, speak. Shaukin, Shireen,
Yes, sir.
Ritika.
Yes, sir.
So,
Yes. Okay. Then again it will move to this position. And again it will come back under the influence of restoring force. Ritika, yes or no? So this motion is also under the influence of restoring force. A restoring force is prevalent on it. Let's take another example. Very famous example. This is mass M. Now what I am doing, and presently it is at rest. Let's say at position O. It is at rest at position O. Okay. Fine. Now, if I pull this mass, apply the force and pull this mass, let's say I bring this mass to this position. I am calling this position as A. I have pulled the mass. I am pulling the mass. So mass reaches this position. I have applied force. After this is the spring. After this, I release the mass. That means I am no longer applying the force. When I release this mass, what will happen? Mass will reach the position O. Yes or no?
Yes, sir.
Then it will move further. Then it will move further backwards. Let's say it will reach this position. Then again it will come back. Yes or no?
Yes, sir.
So it is coming back. Why is it coming back? It is coming back under the influence of a force known as restoring force, which is bringing this mass back again to position O. All these bodies are under the influence of restoring force. So the most important factor for oscillatory motion is that it is a circular motion and a restoring force acts on it.
Sir, circular motion मतलब कि
Sorry, I have written circular motion, sorry. Periodic. It is a periodic motion. Yes, Shri.
ये जो रिस्टोरिंग फोर्स रहेगा वो हमेशा ऑसिलेशन के अपोजिशन में रहेगा.
Oscillation के opposition में. This is the wrong way to understand it. मैंने ऐसा कुछ बोला कि oscillation के opposition में रहेगा. No, approach is wrong. What I said, Yes, anyone, what I said? What is the property of restoring force?
Acting towards mean position.
Restoring, no one understood the property of restoring force.
सर वो उसको जहाँ से स्टार्ट किया वहाँ पे वापस आना चाहेगा.
It always tries to bring the body back to its original position from where the motion started. Now this position, the original position from where the motion started, this position is known as mean position. जो आप लोग बोल रहे थे mean position, this O is mean position here. Okay, so restoring force is a force which brings body back to mean position. Now if you will remember this, if you know this, then obviously it is always going to act opposite to the external force. That's the proper point, Shireen. It's not that it acts against the oscillation. No, ऐसे तो आप क्वेश्चन नहीं सॉल्व कर पाएंगे. The proper answer is that it tries to bring the body back to the original position or mean position. Thereby, you can say that it acts opposite to the external force. Understood or not, Shireen?
Yes, sir, understood.
Now please pay attention. I want your attention, everyone. In waves, we have started with waves. Please do not use your brains, because if you will use your brains, then the things will get out of hands. Okay? Just do what I say, just understand what I say. Because waves is such a topic which you cannot visualize, you cannot see waves. So go by my modus operandi. And Nikita Rawat, you are so close to the institute, still you did not come, huh? Because only single class was there. Now I have told the counselors and everyone that if offline individuals are missing the classes without any valid reason, then they won't be allowed to take the online classes too. Such an important topic. Huh? Starting of waves, 1 month I will give 2 waves. And your friend Disha, she has missed the class. Disha, Zoya, where are they? Priyanka Rao, everyone. Only one student has come, Shivam. Please note it down, everyone, and write in detail that in oscillatory motion restoring force will act.
सर मतलब ओरिजिनल पोजीशन बोला मीन पोजीशन बोले की बात है ना.
What?
Mean position, original position एक ही
Oh
बात है.
yeah. Original position is a layman language. Mean position is a, थोड़ा high class physical language of physics. Where is Disha and Zoya, Nikita? They are not even present online. Message them that this chapter has been started and I won't repeat this class. Now let me see how they will be able to understand.
Excuse me, sir.
Yes, Gauranshi.
Sir, I'd like to discuss something about our test.
Yeah, what happened? How was your test? Thanks for reminding me. Test.
Sir, एक प्रॉब्लम शेयर करनी थी कि लाइक जो टेस्ट होता है मतलब उसमें जो क्वेश्चंस होते हैं वो हमारे लिए मतलब बहुत ज्यादा हाई लेवल के होते हैं कि डिमोटिवेटिंग बहुत फील होती है कि शायद नीट में नहीं हो पाएगा।
तो एको बहुत हो रहा है, आवाज में एको बहुत हो रहा है, थोड़ी वॉल्यूम कम करो गौरांशी। what was your हाँ या टेल मी।
सर को ये बोल रही है कि सर टेस्ट में है ना जो क्वेश्चन होते हैं वो हमारे नीट लेवल के नहीं होते, सर हमको बहुत डिमोटिवेटेड फील होता है। सर ये प्रॉब्लम सबकी हम सबकी।
स्कोर्स तो बताइए।
यस सर।
सर 31।
हाँ सर नॉट इवन क्रॉस 60।
31
ओके।
सर 24
One by one, Shri.
Like 9.
Shanmukha got 100, good. Reshma got 118, very good. Yeah, Shireen, your score?
10 even cross 60.
Score 60 के नीचे तो 0 भी होता है। Yeah, score dear. Shireen and
7 sir.
57, okay. Gauranshi, your score?
सर 24
24, you have improved. In a tough paper.
सर उसमें
It was a
सर उसमें क्वेश्चन लेके बट होता ही कैसे मुझे नहीं आता।
Literally sir it was like too demotivating for us.
demotivating.
यस सर।
सर हमको लग रहा है हमारे बस में 8 और सर बहुत से ऐसे बच्चे जिन लोग के लिए 620 अबव आता है और सर मैंने जितने टेस्ट दिए ना आज तक उसमें 5 मार्क्स से ज्यादा इंप्रूव कर ही नहीं पाई हूँ।
Okay, listen to
सर
me.
ये चीज हो रही है कि आप ये फाइंड डेवलप हो जाता है कि नहीं होगा।
एक मिनट, ये जो मोटिवेशन है ना ये बहुत ही उधार की चीज है। What do you mean by motivation and demotivation? If our inner self is so weak and so fragile, it is made up of glass that it can be shattered by a question paper, then we need to introspect. हमें अपने अंदर झांकना चाहिए। मोटिवेटेड रहने से ज्यादा जरूरी ये है कि इट्स बेटर टू नो दी थिंग्स देन टू स्टे मोटिवेटेड। And there are always two approach to a same problem. Yeah, it was tough. I have told you earlier also. That's why I reduced the cutoff marks. I said yeah, it is tough. I know. But the main point is there are two things, two approach. First approach is you could say I got demotivated, paper was hard. You can blame it on X, Y, Z. Or you can say that there is still scope for improvement. I have to understand some more concepts. I will solve the paper once again free-mindedly. I will see those questions which I was not able to solve or which went wrong, and I will improvise over it. That's it. And I feel bad why you guys are sticking to the first approach, getting demotivated. We are not in the Feb or March. Giving test chapter by chapter. So if one chapter is coming in your test, that means you should have done the dissection of that chapter. It was not the entire syllabus. My dear, we have to change our approach. We are here to learn something. We are not here to show our supremacy that we already know everything. ये बात तो ऐसी हुई कि हमारी बेइज्जती हो गई क्योंकि हम बहुत सुप्रीम हैं और पेपर हार्ड था। It's like this. मैं सुप्रीम नहीं हूँ। The subject is so vast. तो आप कैसे कह सकते हो? ठीक है? Approach बदलो। I expect a lot better approach from you guys. जब मैं कहता हूँ आप लोग में quality है, so I really mean it. And you also show. हाँ. Yeah, tell me.
This means that we are sitting in JEE advanced paper.
So that's yeah, Shri.
और फिर
अच्छा स्कोर करते हैं, तो वी आर फीलिंग लाइक कि हम लोग तो क्लास में भी अपना बेस्ट दे रहे हैं, हम लोग पढ़ाई भी इतने अच्छे से कर रहे हैं, उन लोग के स्कोर आ रहे हैं, तो हम लोग भी कहाँ से कमी लगेगी, हम लोग उसको
यही तो देखने वाली बात है. Yeah, that's the thing you should understand. That paper was hard. Then how come Shanmukha scored 100, Reshma got 118, Manal how much he got? Avni, Manal, Avni का score भी अच्छा होगा. Avni never speaks, but she always gets good marks. Nikita,
Sir, I'll write it after class, sir.
no, you can write in the private chat. Tell your parents to talk with me. I will explain it to them. Shanmukha.
बट सर वो चीज ठीक है, बट उसके बाद उसको फियर डेवलप होता है, तो सेल्फ डाउट होता है ना, बिल्कुल वो नहीं करने देता, ऐसा लगता है कि हो ही नहीं पाएगा.
My dear Gauranshi, आपका स्कोर अंडर डबल डिजिट में नहीं था 2 पेपर्स में. अब वो पेपर की गलती है.
सर मैं बता रही हूँ, बस मुझे
और
बताइए.
अब इस बार आप शौकीन से सिर्फ 7 नंबर दूर हैं. ओनली 7 मार्क्स. तो आपने तो इम्प्रूव किया.
बट तो मुझे नहीं पता ना कैसे हर जगह तो क्वेश्चन लेके लगा है कि मतलब समझ नहीं आ रहा करना क्या है. ट्राई करा बट हुआ नहीं था.
ट्राई कर रहे थे पर हुआ नहीं था. तो इसका मतलब अच्छे से हाँ या
सर अगर सर नीट लाइन के क्वेश्चन से आप टेस्ट करो तो सर बहुत बेनिफिट है. तो सर क्या आपका सेम क्वेश्चन नीट में आ जाए तो सर ये तो रहेगा कि नीट वाले क्वेश्चन एकदम करा हुआ आ गया पेपर में.
no paper is of such constitution that all the questions are tough. इस पेपर में भी सारे क्वेश्चंस टफ नहीं थे. Let me tell you if you are asking. 40% questions were of NEET level. अगर आपके 40% को मार्क्स नहीं आ रहे हैं, that means you are not able to solve NEET level questions. 10% questions were, yeah, I will say they were tough. Only 10%. 30% questions were NEET plus, above than NEET, but not too high. वही सेम कॉन्सेप्ट है, बस थोड़ा सा उसमें मॉडिफिकेशंस हैं. 20% questions were of JEE level. That's the constitution of the paper. Now you can check and reflect आपके कितने परसेंट आ रहे हैं. 40% means 72 marks. Out of 180, 72 marks were from NEET. How many got 72 or 65 or 60? I will give 60 also. How many got 60? Problem is with us. Why don't we understand? We have to improve. Yeah.
Then what should we do?
You have to practice until and unless you solve 70 questions per day. Forget scoring good marks in physics. I have told this 1 month ago. And tell me honestly, how many of you solve 70 questions per day? From that day, how many of you are solving? Ankit Shocking doesn't even solve 10 questions a day. And he thinks some miracle will happen in the exam and he will be able to solve the questions. This is not a miracle. This is effort. You have to make your results.
Correct, solve questions.
70 per day.
No sir.
See?
Sir, first of all I complete the chapter, then sir for 1 to 2 days I solve 100 questions of that chapter.
1 or 2 days. Shocking.
Yes sir.
I told you you have to do it for 6 to 7 months continuously. Practice.
सर तो क्वेश्चन ही नहीं होते मेरे.
इतने क्वेश्चन नहीं होते. आपने जितने चैप्टर्स में उनके पास 20 इयर्स लगा लिए नीट के, आपने उनके एग्जाम्पलर लगा लिए,
Yes sir.
एनसीईआरटी लगा ली,
Yes sir.
असाइनमेंट्स लगा लिए, डीपीपी लगा ली सारी, वर्क पर एनर्जी की डीपीपी हो गई.
तो सर पर डीसी पांडे ने सॉल्व कर ली थी।
डीसी पांडे मैंने रिकमेंड ही नहीं करी है, जो मैंने बोला मैं वो पूछ रहा हूँ। क्वेश्चंस तो बहुत है डियर, आप करिए तो। एनीवे आई विल चेक द रिजल्ट, देखते हैं किसके कितने आए हैं। बट शॉकिंग, डिसअपॉइंटेड हूं, वेरी पुअर परफॉर्मेंस। व्हाट इज योर स्कोर इन अदर सब्जेक्ट शॉकिंग?
Sir, I got 135 as total in bio from 360.
135 in bio.
Yes, sir. Biology paper was out of NCERT.
अब हर एक में प्रॉब्लम है आउट ऑफ एनसीईआरटी। और
Sir, मैं NCERT.
wait a minute, Varanshi, I am talking to Shocking. What about chemistry?
Sir, 135 for 180.
दोनों में 135 that means 270 and 31 in physics that means 301 is your total.
Yes, sir.
Shanmukha, Reshma, how many you got? Manal, what about you? Okay, Ritika, you again went offline, huh? Ritika, I am not able to hear you. Wow, very good. Good. Okay, we will discuss about it later. Okay, let's move on. Nikita, did you give the paper? How many marks did you get? Why are you silent? Okay, anyway, yeah, you tell me your marks, Nikita. So, what we have understood till now, that in oscillatory motion, there is a force acting on a body which brings the body back to its mean position. Yes or no, everyone? Right? There is a force acting on a body which brings the body back to its original position. This force is known as restoring force. Right? Okay, Gaurav. Now, this restoring force, pay attention. Let me talk about this pendulum. Suppose this pendulum moves from here to here, right? And then from here to here. Yes? Let's say, look here. Let's say it moves x distance from the mean position. Let's say this pendulum moves x distance from the mean position. So your restoring force can be given by the formula. First of all, this force is acting opposite to the Opposite to the motion of the pendulum. Yes or no? Opposite to the motion of the pendulum. Opposite to the external force that you have applied. So since it is acting opposite, so what will be the direction of it? How to represent the direction? बोलो डायरेक्शन ऑपोजिट है, कैसे रिप्रेजेंट करें? Aren't you getting it? With minus sign. Force is acting opposite to the motion, so it will be represented with minus sign. So this Fr is equal to minus k x to the power n. Minus k x to the power n.
Am I audible, sir?
Yeah, Ritika, now you are audible.
Sir, there was a technical issue with the thing. I was trying to have a conversation with you for more than 10 to 15 minutes, sir, but it's not audible, and I'm going out and logging in again and again.
No problem. Did you no problem. What was the last thing that you saw in the class? Which topic we were doing when you got disconnected?
Yes.
हम लोग कौन सा last topic कर रहे थे when you got disconnected? Which was the last topic?
Yes. I didn't get you, sir. It's just.
What were we doing in the class when you got disconnected, Ritika?
I was listening restoring force, sir.
Restoring force. So have you understood restoring force? The concept of restoring force, is it clear to you?
Yes, sir.
Okay, so now that's what I am saying, that in oscillatory motion, what is oscillatory motion? A motion which is periodic and in which restoring force acts. Okay, that's what I have said. Fine?
Yes, sir.
And I have written it also, that in oscillatory motion, a force acting on a body which brings body back to its original position. This force is restoring force. Now here I have taken the example of a pendulum. This is my pendulum. If I will apply the force on this pendulum, so pendulum is going to move. Let's say it moves to the right. This is the mean position or original position. Let's call it O. So from mean position it moves to this position called A. Let's say it moves the distance x. X distance this pendulum moves. Fine. Then it again returns back. Then it moves to the left. Let's call this position as B. Let's say again it moves the distance x and it again returns back. Fine. So now I am giving the formula for restoring force. Please see, since restoring force is acting opposite to the motion, that is why it is represented with minus sign. K is the constant and x to the power n. Why x to the power n? Because, can anyone tell me why x to the power n? Yes, Ritika, are you there?
I didn't get your question.
Why is this x to the power n written in defining restoring force? That's my
सर
question.
क्योंकि SHM में जो एम्पलीट्यूड रहता है वो बहुत कम रहता है, तो मेरी
What?
अगर वो पावर n की पावर कम रहेगी, लाइक अगर वो ऑड नंबर रहता है तो वो ऑसिलेटरी मोशन रहता है वैसा वाला.
My dear, what am I asking and what you are replying? मैं पूछ रहा हूँ x की पावर n है क्यों यहाँ पे? Why x to the power n is there? Why x to the power n?
सर शायद वो कितनी बार मतलब टू एंड फ्रो मोशन करके उस पोजीशन पे वापस आए.
It is very simple. Force is dependent on the motion of the body. How did you forget? If you take it to this position, so what do you think? How much force will act? More force will act? More restoring force will act? Yes or no?
Yes, sir.
Greater the distance, greater will be the restoring force. It is directly proportional to the distance.
Yes, sir.
Yes? Shauki? Yes or no?
Yes, sir.
Shireen? So it is directly proportional to the distance. That is why. And why x to the power n we don't know. Here I have taken x. Let's say it is moving x square, x cube, x5, whatever it is. We don't know what the value is. So x to the power n.
Yes, sir.
Minus sign is representing the direction. K is the constant. Understood or not? Ritika, is it clear? This is your restoring force. Now, what values of n we are going to take? N will be 1, 3, 5, 7, so on. Odd values of n we will take. Can anyone tell me why odd values of n are taken here?
Because जैसे कि we took the formula this F restoring force is equal to minus k x to the power n, तो force is directly proportional to minus x to the power n. अब अगर x की जगह पे odd number रखने वाले, अगर वहाँ पे odd number रखेंगे तो उस केस में माइनस तो सामने है तो x पॉजिटिव मिलेगा और फोर्स नेगेटिव मिलेगा. मीन्स दोनों केसेस में अपोजिट मिलने वाला है. और तो दिस इज रिप्रेजेंटिंग एन ऑसिलेटिंग मोशन की वो अपोज करके रिस्टोरिंग आई मीन मेन पोजीशन पे आ रहा है. आई होप आई एम
सर
Yes, Shokyan.
क्योंकि सर
Yeah.
क्योंकि इसकी मोशनल डायरेक्शन है और रिस्टोरिंग फोर्स डायरेक्शन आ गया, मतलब x और f अलग-अलग डिस्टेंस नेट करते हैं.
My please see. I want minus sign in this final expression. I want minus sign in this final expression. So I will keep the values as odd multiples. For example, minus 1 to the power 3 will give you minus 1. But minus 1 to the power 2 will give you plus 1. That's why we are not taking even values. We are taking odd values. Okay. So what will it represent? It will represent, please see. Suppose your force is represented by, let me show you what's the use of taking odd values. Suppose force is represented by minus kx cube. Okay. Now, if you will, okay, yes or no, speak. Now let's say body moves. Look at the same pendulum. Everyone look here. Let's say this body moves the distance of 2 meters towards right. So Gauranshi, what will you take the value of x?
सर फिर से रिपीट करना.
Very good. I am saying body has moved 2 meters towards right. What value of x you will take? Anyone? What value of x we are going to take? Plus 2. Yes, Mushkin. We are going to take positive value. So if you will apply positive value of x is positive because it has moved towards the right side of x-axis. That's why positive values. So restoring force will come out to be minus 8k. That is restoring force is negative, opposite to the motion. That's what the definition of restoring force is.
Yes, sir. Yes, sir.
Now let's say this body moves 2 meters towards B. Yeah. Now you are going to take x equals to minus 2 since it has moved towards the left. So for f equals to minus 2, so minus 2 whole cube, you will get minus 8. So minus 8 into minus k will be plus 8k. So restoring force is positive now. When x is negative, restoring force is positive. That means in this case, please see, in this case when x was positive, restoring force was acting towards left, that is why it was negative, minus. And in this case when x is negative, restoring force is acting towards right, that is why it is positive. And that's what definition of restoring force is. That is why in the formula we take minus sign and represent n with odd numbers. Understood or not everyone? Tell me. Ritika, did you get it?
Understood, sir.
Ritika, I cannot hear you. Did you understand?
So, sir, can you hear me, sir?
Yeah, now I can hear you. Did you understand why we take minus? Did you
Sir,
understand?
can you hear me, sir?
Yes, dear, I can hear you. You are audible. Now tell me.
Yes, sir.
Did,
I can understand, sir.
did you understand why we take odd values of n? Okay, fine. Please note it everyone and write it, explain it to yourself.
I can understand, sir.
Okay, okay. Shireen, Shaukin, Reshma, Shanmukha, Kajal, Gayatri. Everyone got it?
Yes, sir.
Understood?
Yes, sir.
Please note it. So, what is the difference? Done?
Yes, sir.
Everyone done?
Yes, sir.
Shivam, what is the difference between circular motion and oscillatory motion?
Circular.
Gauranshi, difference between circular motion and oscillatory motion.
Sir, secretary, can I answer, sir?
Ritika, my question is, what is the difference between okay, forget circular motion. You tell me what is the difference between periodic motion and oscillatory motion.
Sir, ये
Periodic motion and oscillatory motion difference.
Sir,
Yeah, Shri.
may I?
No. I will ask. Kajal, you tell me. रितिका हाँ, तो जब बोल रहा था तब नहीं बताया, बताओ या गौरांशी.
तो oscillating motion में like उसमें body force लगी होती है तो वापस से उसकी main position को लेके आ जाती है. और जबकि periodic motion में बार-बार एक particular time interval पे वो repeat होती रहती है like.
Okay. Shirin, you tell.
ऑस्किलेटरी मोशन जो है उसमें एक मेन पोजीशन होगी एंड इसमें रिस्टोरिंग फोर्स रहता है एंड पीरियोडिक मोशन को पर्टिकुलर इंटरवल में रिपीट जरूर करती है बट इट डज नॉट हैव मेन पोजीशन.
Good. Yeah. So the main difference is good. Yeah, good Goranji and Shireen. The main difference is that in first of all, oscillatory motion is, keep it in your mind. Oscillatory motion is also a periodic motion. Point number 1. Point number 2, the distinctive quality is that in oscillatory motion, a restoring force is going to act, which is going to bring the body back to its original position. Got it or not? Crystal clear, everyone?
Yes, sir, clear.
Clear?
Yes, sir.
Okay, good. Now, okay, very good. Now, please tell me, I talked about this X thing and I explained to you why odd values of n are taken, why negative sign is applied. I explained all these things to you. Now, you tell me one thing. This X, from where is this X measured? From where is X measured?
Oscillation.
Shaukin?
In position.
The mean position.
Very good. X is always measured from mean position. Write it down. I am writing mean position in short form MP. It's not Madhya Pradesh. It's mean position. Okay. So please see, O was the mean position. So from here, X was measured. Always from the mean position. Yeah, good Priyanka. Let me know when you are done. Are you there, Ritika? Are you getting it?
Yes, sir, I'm getting it.
Understood that X is measured from the mean position?
Yes, sir.
Great.
That's how.
Done, everyone?
Yes, sir.
So there are few points I want you to note as the inference of it, and then we will move on to SHM. Write down point number 1. All periodic motions, point number 1, all periodic motions cannot be oscillatory motion. All periodic are not oscillatory. Yes, because to be oscillatory motion, a special condition has to be satisfied that a restoring force should act. So all periodic motions are not oscillatory motions.
Yes, sir.
Got it? Point number 2. All oscillatory motions are periodic motion. Except one case. Okay. Except one case, all oscillatory are periodic. Is this much clear or not? Hello. Are these 2 points clear to everyone?
Yes, sir.
That all periodic are oscillatory? Sorry, all periodic are not oscillatory, but all oscillatories are periodic, except one case. Can you tell me what that one case is? Which is that case when oscillatory motion is not periodic? There is a case when oscillatory motion is not periodic. Yes, Shireen, Ankit, Reshma, Shanmukha. Which is the case?
I have no idea.
Arey? Ritika?
I don't know, sir. Maybe swimming. I don't know, sir.
You don't know.
पर
Yes, Shobhi.
maybe जब पेंडुलम को हीट करते हैं तो उसमें उसकी लेंथ बढ़ जाती है तो उसकी वजह से उसका टाइम पीरियड चेंज हो जाता है
किसकी लेंथ?
लेकिन ऑसिलेशन
Come again.
सर जब पेंडुलम को हीट करते हैं तो उसमें थर्मल एक्सपेंशन होता है तो वो ऑसिलेशन से परफॉर्म करता है
Okay. No, Earth is example of Shanmukha. Earth is not even example of oscillatory motion, my dear. Earth oscillatory motion है. Earth is not oscillatory, Shanmukha. What am I saying? Understand the point. That all oscillatory motions are periodic except one. So it means that there is one type of oscillatory motion which is not periodic. So I am asking which is that type? Which is oscillatory but it is not periodic?
pendulum in the left
Pendulum
pendulum in the left
in a lift? No. UCM is again not a oscillatory motion, Reshma. In UCM any force acts which brings the body back to the original position.
Spring to
What are you guys saying? These are not even oscillatory motion. Should I to say it in Hindi? एक ऐसी oscillatory motion बताइए जो oscillatory है पर periodic नहीं है. आप लोग जिनके नाम ले रहे हैं वो तो oscillatory ही नहीं है. उसमें कहाँ restoring force लग रही है? Okay, write down. To tell you honestly, all type of oscillatory motions that you observe in your practical life, they are non-periodic. All the motions that you see in your practical life, not in books, practical life. Take a pendulum, apply the force, it will oscillate. But oscillations will keep on reducing due to air friction. Now it is not repeating itself in a regular interval of time. So when it is not repeating itself in a regular interval of time, it is non-periodic. Yes or no?
yes, sir.
But in books it says no air friction, so it keeps on repeating itself. So all the practical oscillatory motions that you observe in your day-to-day life in this world, they are non-periodic. They are known as damped oscillations. Must have heard of this term in class 11. Damped oscillations.
Sir, can you repeat once more, sir?
I said that all the practical examples of oscillatory motion, that means all the oscillatory motions which we do in our real life, not in books, in real life. Take a pendulum, apply the force on a pendulum, Ritika. What will happen? After some time, pendulum will stop oscillating. Yes or no?
Yes, sir.
Why has pendulum stopped oscillating? Because it has lost energy. It has lost energy. So when it was losing energy, its oscillation reduced. Now it is not taking same amount of time that it used to take at the start of the motion. So when time is not same, then how can it be periodic? Because the condition for a motion to be periodic is that it should be repeated in a definite interval of time. Now time is getting reduced. Oscillations are becoming small. So it is not periodic. Such type of oscillations are known as damped oscillations, where energy is lost during oscillations. Yes.
वॉल में वॉच जो लगा रहता है, वॉच जो होता है वॉल, उसमें ऑसिलेशन नहीं करता है अलार्म मॉडल, वो तो हमेशा ऑसिलेट करता है.
It is in the glass frame. No air friction is there.
Yes. तो फिर वो ऑसिलेट periodic होगा.
Then it is periodic. Okay. So write down. Those motions where energy is lost are known as damped oscillation. Understood or not, everyone? Ritika, got it or not?
Yes, I got it.
Yes, Priyanka, yes. Yes, Shri.
Then we are going to study the oscillations जिसमें energy loss ही नहीं होने वाली है.
Yeah, 95% cases are that in your course, but one special case is there, damped oscillation. We will do that also.
Okay, sir.
तो ऐसा से एक्सपेरिमेंट भी होता है ना लैब्स में स्कूल में.
Yeah, experiment is there in the lab.
ऐसा से एक बॉम्ब को मारते हैं सेम फ्रीक्वेंसी वाले को तो वो आगे भी सेम फ्रीक्वेंसी के साथ जाता है.
Yeah. और आप लोग बहुत तेजी से मार देते थे, हाँ? और टीचर कहता था धीमे धीमे मारो. Yeah. Teacher used to shout, "No, don't hit it so fast," and he used to, and Bob is like,
There was from Tamil and she used to say, "Guys, sit down, you don't have to do it right now."
Can you tell me the reason why was teacher stopping you to not hit it that fast when you were measuring the frequency or time period, whatever, or length?
Obviously, we were naughty.
No, naughty is not that. Why was he saying that hit the pendulum softly, don't hit it too hard?
Because
To have clear observation.
So students think that teachers stops us because the pendulum will break. He is trying to preserve the property of the school, right? But that's not the case. There is a scientific reason behind it. That's my next topic. Moving on, is this done? Gauranshi, did you understand?
Yes, sir.
Okay, moving on. Put on the heading, and that's the topic SHM. What is the full form of SHM? Okay. Simple harmonic motion. No, this is a very beautiful word and a very beautiful chapter. What do we mean by harmonic motion? In harmony, everybody is saying, yeah, what?
तो oscillation को भी harmonic motion बोलते हैं ना?
Oscillatory.
Yes, good. Harmonic means oscillatory or periodic, but oscillatory is a better word. oscillatory motion. This is oscillatory motion, but mind you, it is the simplest form of oscillatory motion. What do we mean by this? Simple harmonic motion. What is the meaning of simple? Harmonic, I have told you, it is oscillatory. What is simple? Why simple we are using here?
सर इसके अंदर जो f माइनस सर f इक्वल टू माइनस kx रेज़ टू पावर n हो तो सर इसके अंदर n की वैल्यू 1 होती है.
Very good, Shocking. Good. Awesome. Remember oscillatory motion? What was oscillatory motion? Restoring force was given by minus kx to the power n. Shocking? Now I believe you that you have studied waves in a proper way. X to the power n, right? Now here, value of in SHM, value of n will be 1. Why? Because it is the simplest case of oscillatory motion. Simplest case of oscillatory motion. So F restoring comes out to be minus kx. It is the simplest case of oscillatory motion. Write it down. I can, for example, if you are in oscillatory, look here, in oscillatory, if I write the expression fully, so it will be something like this, minus kx, 5 and so on. Yes or no? Idhar dekhiye. Right? Now, this value, just the first value, will give you SHM. Just the first value will give you SHM, simplest harmonic motion. Understood or not? Avni, Gayatri, Gauranshi, Reshma, Shanmukha,
Yes, sir.
Priyanka, Swati, Shireen, Ritika,
Yes, sir.
Yes, sir.
Manal, yep. Now, this is SHM. Understood? Many students study waves and all those things, SHM waves, they never know what actually SHM is. There is one more misnomer. Students confuse that SHM is a wave. Write it down in bold letters. SHM is not a wave. It is a type of a motion. SHM is a type of motion. It is not a wave. Okay, pay attention now, very interesting thing. I want all of your attention here. Pay attention. Everyone. And I want you to respond, minus kx. Minus kx. That means x to the power 1. Yes or no? Speak fast. X to the power 1. Right?
Yes, sir.
Yes, sir. Sir.
What type of motion this is? Linear motion? Straight line motion?
Yes, sir. Maybe.
F is minus kx. Hello?
Yes, sir.
कैसी motion होती है? It is a straight line motion. Put on values of x. It will be linear. Yes or no?
Yes, translation.
Yes, sir.
That is why some scholars call SHM as simple line motion. Motion performed in a line. Simple line motion. It is linear. Look at the power of x. If the power is x square, then the motion will be curved in the form of curve. But it is x to the power 1. linear motion. Linear. Got it or not? Please look here. Look. You can note it later. Suppose this is your pendulum. So, if this pendulum, pay attention everyone, if this pendulum is performing big oscillations like this, big oscillations, you have applied lot of force. Is it linear? Is it SHM now? This is not SHM because movement is not linear. Movement of block is not linear. Movement of your bob is non-linear. This is not SHM. No. This is curved motion. This is curved motion. But if you apply a small amount of force, now this is linear motion. Yes or no? Now this is SHM, small oscillations. That is why in school your teacher used to say, when you were measuring the frequency of this pendulum or something like that, he used to tell you or time period that make small oscillations, thoda sa force lagao. It was not because that pendulum will break. It was because if you will apply more force, the SHM will change into oscillatory motion. It will no longer remain simple harmonic motion, because simple harmonic motion is a linear motion. Got it or not?
Yes, sir, understood.
Everyone?
Yes, sir.
Understood? Shocking. So you were not wasting the property of the school. In fact, you were not doing SHM. Now this is linear. So very small oscillations we are going to consider in SHM. Very small oscillations. Ritika, are you getting it?
Sir, I'm getting it.
आगे समझ में. Okay. So I think that's it for today. I will see you all tomorrow. I hope Ritika you understood everything. Everyone understood everything. So very interesting topic we have started with.
Yes, sir. Thank you so much, sir.
Okay dear, bye. Everyone bye. Have a great day. Take care.
Thank you, sir.
Thank you, sir.
Thank you, sir.
Thank you, sir.
Thanks to you all.